All right, y'all. So we are not going to do a peer deck today. We are going to kind of stick to just our PowerPoint and see how that goes. All right, so make sure you have your attendance done in Canvas. You've opened your digital notebook. We're going to put just, I think, 2 vocab words in there, and then we have our 3.1 Google Doc. Okay, so we are going to start on chapter 3. So why are identical twins rare? And by the end of today, you guys are going to gather some evidence on why offspring from the same parents have different gene combinations. So for your first 2 minutes, your first activity, you're going to revisit a question on how sisters with the same parents end up with different gene combinations, and then you're going to explain using your knowledge from previous lessons. So go ahead, go into your Google Doc, which is on Canvas, and answer the warm-up question. You've got 2 minutes. All right, y'all, so hopefully you did your warm-up in your Google Doc. All right, guys, so hopefully you did your warm-up in your Google Doc. It should look something like this. You were to answer in that little pink box right there. The next activity is not in the Google Doc. We're just gonna kind of have a conversation together, and then we will move on to a reading. So activity 2, we're gonna review our unit task again. We've got a chapter 3 question since we started a new chapter, and then we're going to revisit 3 possible claims that we looked at last chapter. All right, so remember, we are helping the Bay Medical Company determine how to breed spiders that will produce offspring with a trait for medium silk flexibility. Remember, medium silk flexibility is what we wanted in order to have good silk flexibility. They wanted medium silk flexibility because low silk flexibility wasn't stretchy enough, and high silk flexibility was a little too stretchy. So that medium silk flexibility, we're sitting right at that happy medium. All right, and so in order to help the researchers, we need to determine why the Darwin's bark spider offspring have different traits for silk flexibility. So why do each of these offspring have different silk flexibility traits? And why are they different from their parents? Right, so these were the gene versions that we looked at. I think it was last class. It's been so many days because of the snowstorm. But these were the gene versions you should have had for that activity that we did in Canvas last week. All right, so chapter 3 question: why do the Darwin's bark spider offspring have different gene combinations even though they have the same parents? All right, why do Darwin's bark spider offspring have different gene combinations even though they have the same parents? Now, here are the claims. All right, let's take a look at the claims. Remember, we've been investigating these, and they have kind of been revised to reflect what we have learned so far. So the overall question of this unit was, why do traits for silk flexibility vary within this family of Darwin's bark spiders? And so claim 1 says they have mutations that affect their traits. Claim 2 is saying that the offspring's traits depend on which parent an offspring received more copies of genes from. And then claim 3, the offspring received different combinations of gene versions from their parents. Now, this next slide is going to ask you, which claim do you find most convincing? And so I'm going to go ahead and go back to the previous slide because the slide doesn't show all of the claims. So I'm going to go back to this slide. In the chat, since we're not doing Pear Deck, I want you to tell me which claim you think is correct right now. It may change at the end of this lesson. It may change next week. But what claim do you think you can support right now? Go ahead and put it in the chat. Just because somebody else is saying it doesn't mean you have to say it. So go with whatever your gut is telling you right now. You could send me a private message if you would like to. All right, so I've got 4 people responding right now. The question was, what claim would you support right now? All right, I'm seeing some 2s and 3s. Anybody think claim 1? All right, so no, not claim 1, Elias. All right, so I'm seeing a lot of 2s and 3s. Maybe leaning a little bit more towards claim 3. All right, so we're going to look at these a little bit more. In next class, we're actually going to take a deeper look at claim 2 and try to determine whether we can get rid of it or keep it. All right, so for our next activity, we're going to do a reading. All right, we have a new article. It is called Why Are Identical Twins Rare? And so what this article is going to help us answer is this question. So this is our investigation question today. How do organisms get their genes? All right, how do organisms get their genes? And so when you read this, you're going to try and answer that question. All right, I told you guys it's called Why Are Identical Twins Rare? You guys are going to need to add at least 3 annotations. So if you go back into your Google Doc, I zoom in a little bit, you have your instructions here. So you're going to open up the article and amplify. It's linked right there for you. You're going to read and annotate the article, adding at least 3 annotations. And so since we're not doing a pair deck, I did pair decks with my classes yesterday, you're just going to put one of your annotations in the chat. All right, so you're going to read and annotate the article with at least 3 annotations and get one of your annotations to share with the class and post it in our chat. Okay, so go ahead and go to your Google Doc, open up the article and amplify, and I will start this 10-minute timer. Alright, y'all, hopefully that was enough time for you to read, add 3 annotations, and then some of you have already put your one of your annotations in the chat, so thank you. Alright, I'm going to read a few of those annotations while everybody else is getting finished up. Alright, so in identical twins, fertilization happens only once. We got another one that says the cells of these twins inherit the same combinations of gene versions because they were produced from the same egg and sperm cells. Because they have the same genes, the identical twins will have identical genetic traits. Does anybody have any twins in their family? My grandpa, so my mom's dad, is a twin. Does anybody else have any twins in their family or is a twin? Kendall's mom and aunt. All right, Natalie says each parent randomly passes on only one copy of each gene, so there can be lots of possible combinations of genes passed on from two parents. The many possible combinations of genes are what give us variation. That's a good one. This one is important when we continue on this chapter. So Natalie's annotation is a good one. It looks like AJ and Kaden picked the same annotation. So it says identical twins look so much alike because they have the same proteins, and they have the same proteins because their genes are the same. Mimi says genes are organized on matching pairs of chromosomes. All right, once you get done, make sure you put your annotation in there. Right, we're just gonna kind of discuss these annotations a little bit. Anybody else have any twins in their family except for Kendall and myself? They're not very common, so not a lot of us may have twins in our family. Marlene, your cousins are twins? Right, so I'm going to go on to our new vocab. So these two vocab words that we're about to go over, you guys should have seen in the article. All right, nobody really pointed this one out. And it is a big factor when we're talking about genes and proteins and reproduction. And so this vocab word is sexual reproduction. Make sure you put it in your digital notebook. It should be on chat. Since we are on a new chapter, it's on chapter 3 vocabulary. All right, so sexual reproduction is the process in which two parents pass on their genes to create offspring. So the question that you guys needed to answer, I'll go back to the vocab word in a second. How do organisms get their genes? This vocab word is kind of helping you with answering that question. All right, so how do organisms get their genes? And so through sexual reproduction is a good start, right? So sexual reproduction is the process in which two parents pass on their genes to create offspring. All right, so you guys knew that we get our genes from our parents somehow, some way, right? And so we also inherit those genes. So to receive genes from a parent. Right, so that is our other vocab word, sexual reproduction and inherit. So inherit means to receive genes from a parent. All right, make sure you have those two words down. If you guys ever want to go back and you don't know what words we looked at or what vocab words we did that day, I have added in the module for today with the slides. If you go to lesson 3.1, why are identical twins rare, you'll see the slideshow, and then below it you'll see the vocab words that we did. It's not really loading right now, but give it a second. You'll see the vocab words and maybe some important ideas that we did that day. All right, so if you ever need to go back to these slides and go back to what you should have in your digital notebook. All right, we're almost done. I'm going to get out of here a little bit early today. So we're going to do the sim together right now because this is the last thing that you have on your Google Doc. We're going to take the time to do it now instead of waiting later. So what we're going to do is we're going to open the sim and we're actually going to mate the spiders to observe some genetic inheritance. All right, so in your Google Doc, the sim is linked. All right, so what you're going to do is you're going to open up the simulation. Launch that sim, and I'm going to do it at the same time you guys are doing it. And so this is going to be actually something new that we're looking at. We've only been looking at the 6 spiders right there. We've only been looking at their traits, their different features, but we have never mated these spiders. Okay, so I'm going to go back and forth between my instructions, or I might just split my screen here between my sim and my instructions so you guys can see it at the same time. All right, so the first thing that I need to do is I need to mate a female and male spider by dragging one spider to another. All right, so I'm going to pick the prettiest ones. I like Anne and I like Leo. So what I'm going to do is I'm going to drag Anne over to Leo. Okay, and I should see a page that looks like this. Now, when you pick your spiders, you mated which female spider and which male spider. I'm not going to put it here because it will show up on your screen. But I mated Anne and Leo. So that was my female and my male spider. All right, now I'm going to just keep following these instructions on the Google Doc. I'm going to press create reproductive cells. It's kind of small down here at the bottom, but you should see it. So create reproductive cells, and it'll come up with a page like this. All right, these are the sperm cells, these are the egg cells. And once you see this page, you'll click another button. It'll also be down at the bottom that says randomly fertilize. Now, it's going to give you 4 different offspring. So you're going to see a picture that kind of we've seen before, where it has the mom and the dad spider, and then it has 4 different offspring. All right. Now, I want you to focus on a feature. So you can pick any feature up here at the top. All right. Any of those features you would like to look at, bristle, anything except for body size. I'm not sure why it keeps telling us to not look at body size, but anything but body size. Okay. You'll put the feature that you focused on in that green box, and then it's got 2 questions. Once you pick that feature, so I'm just going to pick bristles. Right? I know it's kind of small on here for you, and it's still kind of small on here for me, so I'm going to zoom in just a tad bit. It tells me the trait. It tells me their gene version. And then if I want to go actually look at their cells, you can always click on the spider and it will give you the inside of the cell with the nucleus, the ribosome. It'll tell you the gene version up here. It tells you the proteins that are in the cell. And then if you want to go back, you just press that X and it'll take you back here. All right, your 2 questions over here in the purple and the yellow boxes says, how do the offspring's traits compare to the parents' traits? So right here, you're comparing, for me, it would be sparse and dense for my 2 parents, and I'm comparing what the offspring has, and then how do the offspring's gene compared to the parents' gene versions, right? And we know that gene versions are this R1, R2, R1, R1. If you're looking at silk flexibility, it would be F1, F2, F1, F1, and so on, whatever gene version your spider has. You're comparing your parents and the offspring. All right, so take some time to do that. It's kind of neat to actually get to mate those spiders and look at the offspring and how those compare to each other. All right, so the last thing after you get done with that simulation is your exit slip. So you're going to complete and submit that exit slip for lesson 3.1 on Canvas, and make sure you guys get that done before I see you next. All right, not on Friday, but by next week. Okay, so that exit slip in Canvas will be due by next week. All right, any extension links you guys want to go ahead and look at, you can get a little bit more information. Other than that, I'm letting you out here a little bit early. I don't have anything else to give you guys. If you guys have any questions, let me know, and I will see you guys tomorrow.